Yes. Next topic is, superposition principle. What happens when you have more than two charges? So we have to calculate, the net or the resultant force, on any charge due to other given charges. For example, if you have to find out the force on the net force, electrostatic force on this charge Q due to these two charges Q1 and Q2, we use the basic rule. First we take this one and this one. This is the charge under consideration because you need to find out the net force on this. So for that purpose we have to calculate with the help of the Coulomb's law the force exerted by this charge on this charge which is under consideration. So with the help of the Coulomb's law, K, Q1, Q2, which is Q in this case, divided by R square, the distance between the two. And then we use the same Coulomb's law for these two charges and we add them like vectors, right? So then the resultant force, for example, this is the first force, this is the second force, we add them like using the law of vector addition. Take the first vector, bring the beginning on the end of this one and join the first to the end. So this will be the resultant. So we will do some questions later on. This is how we calculate. So we are going to use this principle. We call it the superposition principle to do this example, which is 15.2 example. You see, you have three charges along x-axis line. The positive charge is at x is equal to 2 and the other positive charge 6 microcoulomb is at the origin. You see, if you take this as the x-axis line, this is 0, origin. Right side you have positive, okay? Left side you have negative. So this charge is Q1 15 microcoulomb is at 2 meter from origin 0 up to here. How much? 2 meter. And this charge is at origin 0. This is 0 origin here. So Q2 is at the origin. Right. Where must a negative charge Q3 be placed so that the resultant electric field on it, on Q3, should be 0. You see, now we have to decide the direction of the forces on Q3 due to these two charges Q1 and Q2. You see, positive charge, positive charge. Bad luck for this negative charge is that it is trapped between two positive charges. So it will pull it to this side and this will pull it to this side. So you can easily see that the force on charge Q3 due to Q1 is this side, positive x-axis. And the force on Q3 due to Q2 charge is along the negative direction. So according to the given condition, resultant force will be equal to 0. And the resultant force mean you add these two vectors. This is the given condition. Resultant force will be 0. Now, two forces you have to add. F13 positive, right? And F23 negative. Must be equal to 0. Right? So this is the key idea which is given to you. In fact, this is the given idea, right? You add two vector forces and you will get 0 answer. You have to find out, x. Okay? X you have to find out. Now, I'm going to use Coulomb's law. The basic idea is you will use the Coulomb law. For example, here, K, Q2, Q1, Q2 or R squared. This is the rule, right? But now you have 1 and 3. 1 and 3. So, distance between 1 and 3, this is 1 and 3. R1 and 3 is equal to how much? This is total 2 meter, right? This is 2, this is x. So 2 minus x, you will get this one, which is equal to 2 minus x. Okay, minus k, q1, q2 or r squared. Now you have 2 and 3. So 2 and 3. 2, 3 equal to 0. This is R2, 3, which is equal to x. Right? K goes with K. Right? So K goes with K and also Q3 goes with Q3. So you are left with Q1 minus, if I take this on the other side, you will get, by the way, Q2 over R, like this one. Right? Okay. So, K and Q3, both are left. Right. So, now, I can use it here. So Q1 how much? Q1 is 15 micro mean minus 6. R13 how much? 2 minus x square is equal to Q2 6 micro over R23 x squared. This goes with this, and if I divide by 3, so I would get dividing by 3 both sides, just to simplify. The purpose is to simplify as much as you can. Now I cross multiply 5x squared is equal to 2 minus x squared. So 2 square 4 plus x squared minus 4x. So you get 8 plus 2x squared minus 8x is equal to 5x squared. Allow me to go to the next page. I have blank page for you, just to do the things here. Okay, I'm taking this here up, so I simplify it. 5x squared, I take all, let me, 8 plus 2x squared minus 8x. So I take all on the left side, so 5 minus 2, you will get 3x squared. Minus 8x, you will get plus 8x. Plus 8 minus 8 is equal to 0. Right? 3x squared plus 8x minus 8 is equal to 0. This is the quadratic equation, right? Quadratic in x. So x, you see, if you have ax squared plus bx plus c is equal to 0, ax squared plus bx plus c is equal to 0, this is quadratic equation. And the solution is x is equal to minus b plus minus, yes, b squared minus 4ac over 2a. Right? So you would get minus, now you see here, a is equal to 3, b is equal to 8, c is equal to minus 8, minus b plus minus b squared minus 4a c over 2a. Yes. All right. So you would get x is equal to two values, plus and minus, right? So we take only positive value, which is 0.77 meter. This is how you calculate. By the way, there is always another way of correctly using other formulas to find the unknown. So instead of using the quadratic, you can use taking the square root of both sides of last equation. I just deleted, by the way, and you can find out. But it doesn't work in all and every cases, so it's good to use quadratic, by the way. Right. Then electric field. What is electric field? You see, whenever you remember, once you have gravitational field like magnetic field, you have electric field. And what is that? Whenever you have a charge in any location, so it can affect, it can exert force of attraction or repulsion on other charges around. So the space around that charge where it can influence, it can exert the force of attraction or repulsion on other charges, that field, that space is called electric field. How to verify that yes, you have in that location some charge? So what we do, for example, if you have this charge, originally Q charge is present here, you bring another charge just to check that yes, you have electric field due to that charge. You bring that charge, we call that charge a test charge. So it will exert a force on that test charge. So the force on the test charge is called electric field or electric field strength. Right? Electric field E is equal to force per unit charge, which is Q0 or Q0. F is the force in Newton. Q is the charge in Coulomb. So the unit of E is Newton per Coulomb. Right. Now, what is force F? F force is given by Coulomb's law, K Q1 Q2 over R squared. Now you have these two charges, Q and Q0. So Q and Q0. Right? if I use this rule again, force K Q over Q naught or R square divided by Q0. Q0 goes with Q0, so you get electric field E is equal to K Q by R square. This is one relationship. Sometimes you can use this equation, and it depends what is given and what to find out. So different expression K with this is electrostatic constant and the Coulomb's constant K, or sometimes we write Ke, right? Right. So the direction of electric field E, capital E, which is the electric field intensity or electric field strength, we call it. It has the direction, of course. What's the direction if you have a positive charge outside, away from the positive charge? Of course, it's in all directions, by the way, in general. So, for example, if you have any point of interest P here, so at that point we can say, okay, this is away from the positive charge. And if you have negative charge, into the negative charge. Of course, again, it is from all directions, spherical directions, but right now, if we have any point of interest A here, so we say, okay, this electric field E direction is towards inside the negative charge. Right. This is what I am talking about. That if you have a positive charge, it sets up an electric field pointing away from the positive charge. Positive charge away from it, always in all directions. And if you have a negative charge, from all directions, negative charge into the negative charge. Okay, this is positive charge. So this is how we represent the directions. Now, again, superposition principle, the same thing we used in case of the net force when different charges are acting forces on one charge which is under consideration. Similarly, what about every electric charge has this electric field due to that. So we add all the electric fields, and at any point, for example P, we can find out by adding all these vectors. Which vectors? Electric field E. So if you have 1, 2, 3, 4, 5, 6, 7. So the basic rule we just finished, that KQ by R square, electric field strength. So instead of Q capital, I can use small q, not a big deal. So this is the basic idea. So if you have Q1, Q2, so you will be adding KQ1 by R1 square plus KQ2 by R2 square plus KQ3 by R, and so on. You keep on adding like vectors. So you have to decide the direction of capital E electric field, and whether, for example, if you have 3 charges, so you would write E is equal to KQ1 over R1 square. If you have 3 charges like this one, okay? If you have 4, you will continue adding. So this is how this works. This is the same thing, by the way. Electric field lines pattern, you see. This is what we discussed. And now if you have, instead of single charge, you have 2 charges, okay? And we call it dipole. Dipole means 2 poles, you have 2 charges, and we use the basic rule that from the positive charge, all directions outward. and negative charge, all directions, capital E, electric field into the charge. And you see, we can trace it by using the compass and the iron filings to, we can draw these lines on the piece of paper. It should be like this one. Now, where the lines are closer, the field, electric field is very strong. And where the lines are away, the field is weaker. Number two, keep in mind that we sometimes in the questions it is given, okay, find the ratio between the two charges. So unit is given, magnitude of the charge is not given. So what is the idea? You calculate the number of the, you count the number of the lines away or into the charges, and you can easily find out the magnitude. If for example you have 19 lines going out of this positive charge, so its magnitude is 19 in the given unit, for example microcoulomb. Similarly here, so you can, the magnitude of the charge is proportional to the number of lines going into or out of the charge. Right. So for example, if you have like charges, these two positive charges, again using the basic rule that positive charges away from it, it's going there, and since there will be force of repulsion between the two like charges, both positive charges, so there is no electric line somewhere between these two. So what does it mean? As I told you earlier that if the field lines are closer, field is stronger. There is no field line here, so electric field is 0 at this point, for example, right? If you have the same magnitude, it will be exactly 0 at center point. But if you have different magnitudes, yes, still it will be 0 somewhere in between, not exactly at central point, by the way. It depends upon the magnitudes of the charges. Similarly, you can see this here, okay? The magnitude is not equal, right? So that is end of this chapter. So we will come up with the tutorial of this chapter soon, inshallah. Don't forget to drop your feedback and suggestions on after subscribing, pressing the bell icon to subscribe, so that whenever I upload new videos, so you will be notified, inshallah. Thank you very much and have a nice day.